I'm going to go through a few problems from the Math 3 Unit 1 Worksheet 6, and we're going to start with number 2. So here we have a what we call a piecewise function. Piecewise function means we've pieced together two or more functions, and as you could see in number 2, the top function I'll highlight is linear absolute value, and right after that function comes the restriction, so we're only going to use that function when x is less than or equal to -1. And then the second piece is right below it, it's exponential, and we're only going to use that piece when x is greater than -1. And notice there's no overlap in your domain restrictions. So find g of 0. So when you're finding g of 0, you need to know which piece do I use. Do I use the top piece that I highlighted in green, or do I use the second piece, which is highlighted in yellow? And that's when you look at the domain restrictions. So is 0 less than or equal to -1, or is 0 bigger than -1? Well, 0 would fall into the second category, and so then you plug in 0 into the second equation. So it's going to be 2 to the power of 0 plus 1 minus 3. 0 plus 1 is 1, so it's 2 to the power of 1, which is just 2 minus 3. So we're end up with -1 as an answer. For part B, we want to plug in -2. Well, which restriction does that belong to? Is -2 less than or equal to -1, or is it bigger than -1? And if you have trouble with this, remember your number line. Right, here's 0, -1 is to the left, -2 is to the left of -1, so it's less than, so -2 belongs to the top piece. And so we're going to plug in -2 into that top piece. When we do, we end up with 4 minus 2 times the absolute value of -2 plus 3, which is 4 minus 2 times the absolute value of 1, which just becomes 4 minus 2, which is 2. Then next, part C, we're going to plug in a 2. Well, again, which restriction does 2 belong to? It belongs to the one on the bottom. And so we're going to get 2 to the power of 2 plus 1 minus 3, which is 2 to the third power minus 3, or 8 minus 3, which is 5. Now we want to, for part D, we want to plug in a 1. Well, 1 would belong to the second part. So 2 to the power of 1 plus 1 minus 3 is 2 to the power of 2 minus 3, or 4 minus 3, which is -1. And lastly, we want to plug in -1. Now both restrictions, there's a -1 involved in writing both those restrictions. Which one does it belong to? Well, the first one, the top one, says less than or equal to -1, so -1 belongs to the top restriction. And so we're going to get 4 minus 2 times the absolute value of -1 plus 3, which is 4 minus 2 times the absolute value of 2. Don't do 4 minus 2, you got to follow order of operations, multiplication before subtraction. So this is 4 minus 2 times 2, which is 4 minus 4, which is 0. And now everything in number 2 is taken care of. Skip down to number 6. So we have two pieces here. The first piece is linear with the restriction x less than 3. So what I'm going to do, I'm going to highlight on the x-axis everything less than 3. Okay, right there. And then the second piece is quadratic, and that's for everything greater than 3. So everything over there. So there's this, it's not part of the graph, but I'll put it up here. It's kind of this dividing line between the blue and the green, and on the left side of that line you're going to put the first piece, and on the right side of that line you're going to put the second piece. So let's start with the first piece. Sometimes it's hard to draw that whole thing just on the first piece. It's okay to draw the whole thing and then erase what you don't want if that helps. But this is linear, and you have to plug in the critical point here. Where things are changing, you have to plug that in. So on the top one, I'm going to plug in a 3. It's going to give me a point when I do that. So I get f of 3. Well, I don't want to write f of 3. I'm just going to write y equals. So y is going to be, if using the top one, negative 2 times 3 minus 1, which is negative 6 minus 1, or negative 7. So 3, negative 7 is something I want to graph. So 1, 2, 3, 4, 5, 6, 7, right there. Okay, that's part. I'm going to put an open circle there because it's not equal at that point, but that's where our left side is going to end. And then I'm going to pick another point because it's a line, and you need 2 points to draw a line in the blue region. So I'll pick 4. And I'm noticing my error here, and I'm going to fix it. I made my boundary around negative 3, where it's around 3. So this actually goes all the way to positive 3. That's where they cross. And 3, negative 7 is right here. That is better now. Okay. So now I'm going to pick another value. I'll plug in 0. So y equals negative 2 times 0 minus 1, which is 0 minus 1, which is negative 1. So if I plug in a 0, I get negative 1 as an answer. So that is actually included in the blue part, so I'm going to color that in. And there's my line. Keeps going on to the left, so I'm going to put my arrow on the left side. Not going to put an arrow on the right side. So that's the first piece of my piecewise function. Second piece, I'll do in green. I need to plug in a 3 into the second equation. So negative 3 squared plus 10 is going to give me negative 9 plus 10, which is 1. So 3 comma 1, and open circle again because it's not equal. So that's where it hits the boundary line. And then it's quadratic, and we need to get a sense of what this looks like if we were just to graph it without any restrictions. So I'm going to sketch over here. That plus 10 tells me to move up 10. So I'd go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be my vertex. And we just saw that when we plug in a 3, we get a 1. So that would be the right side. This would be the left side. So you see how it's moving down. And we actually found a point that this goes through at 0, 10. So I'm going to, well, that's not included. So it's, this is the part that we're interested in. So I'm just going to find a point to the right. I'll plug in a 4. I get negative 16 plus 10, which is negative 6. So 4, negative 6 is a point here. Right there. And so this thing is curved. It's not a straight line because you see the piece of the picture that we have here. And that's our piecewise function. So the two pieces together to make that one function. And let's finish with number 12. Actually, we're going to do 12 and 17. 12, we got 3 pieces. So the first piece I'll highlight is from x less than or equal to negative 3. Right there. The second piece goes from negative 3 to 1. And the third piece goes from 1 to 2. I need to finish one thing in number 6. Number 6 says graph the following, show significant points. We did that. State the domain and range. I did not do that. So for the domain, left to right, we have 2 intervals. The one in blue, which went from negative infinity up to 3. And the second one started back at 3 and went to infinity. And we put a union sign between them. The range, the lowest this goes is from the green. So you notice the green part goes all the way to negative infinity. And everything's covered all the way up to infinity. The blue goes up to infinity. So that's your domain and range for number 6. The one we're working on, number 12, doesn't say to state the domain and range. It just asks to graph the following and evaluate the given values. Okay. So we're going to evaluate some of these values. F of negative 8. And this might help us out with a little bit of the graphing. So I'm just going to go ahead and evaluate first. F of negative 8, actually 8 is not, 8's way outside of this, so this does not exist. Because our domain stops at 2. Here's 2 right here, 8 is to the right of that, and nothing, there is no graph to the right of 2. 0 belongs to the second piece, so it'd be 2 times 0 plus 1, which is 1. So this goes through 0, 1, and I'll plot that. 6. Oh, I am reading this wrong. I apologize. I read negative 8 as 8. Mixing stuff up. Negative 8 is on the graph. Positive 8 is not. That's how I was reading it. But negative 8 is. Negative 8 belongs in the first category. And anything in the first category is equal to 5. So that goes with the point negative 8, 5. That's a little off the chart. about right there. And then the last one, 6, positive 6. Well, that's past 2 right here. And there's no graph there, so it does not exist. Alright, now we're looking to graph this thing. So the first graph, the first piece is the y equals 5. And so y equals 5 means all the y values are 5. So all the way across. So it's this horizontal line, arrow pointed to the left, but it's going to stop at -3, and it's actually colored in circle there. The reason is because we have x less than or equal at that point. So then we are going to pick up with the second piece. I'll do this in green, and I'll scoot it over a little bit. So we're working with y equals 2x plus 1. And we have to know what happens at the boundary. We have to know what happens when x is -3. And we have to know what happens when x is positive 1. So I'm going to plug in a -3. And I get -5. So -3, -5 is something we need to plot. Open circle there. And then the other one we need to plug in positive 1. And we end up with 3. So 1, 3 is another point we want to plot. Now I'm noticing an issue here. At -3, and it's not an issue with what I did, it's an issue with the problem here. And we can correct this pretty easily. At -3, there's two answers. There's the answer from the first piece, because which is 5, and there's an answer from the second piece, which is -5. So what we're going to do is we're going to take this sign right here and cross out the equals. So we're going to make this an open circle, because you can't have two different closed circles right above each other. It would not be a function if that were the case. And this is linear, so we'll connect the points here. Okay, that's my second piece. Third piece in blue. We have to know the endpoints again. So we have y equals x squared, and we need to know what happens when we plug in a 1. And we need to know what happens when we plug in a 2. So first one we end up with 1, 1. Second one we end up with 2, 4. So 1, 1, open circle there. 2, 4, open circle there. And remember, this is a parabola. There it is. You know, if we continued it, I'll erase this part, it would look like this. Vertex would be at 0, 0, but we don't want that graphed in that region, just the piece that I graphed. And we did it. Lots of little steps here. Be careful, check your work. You can read something wrong like I did, and you'll have to just go back and fix it. Alright. Last one I want to do with you is, I want to do 17 and 19. So not the last one, but let's look at 17. 17 for the interval negative infinity to negative 1. I'm going to highlight that interval. Okay. State what type of function is represented. Well, that's when I get our V shape. So that's a linear absolute value function. And then from negative in part B, write the equation for the linear absolute value function. Okay. So it kind of gave you the answer in part B to part A. So normally the absolute value, the parent graph is at 0, 0, so we see that it's been moved up to left 2. And so we have y equals something, absolute value x plus 2 plus 2. And then we could see our slope of the right side is down to left 1. So a is negative 2 over 1, which is negative 2. I'm using the slope of right side. That's a little trick we can use. And so my function is y equals negative 2 x plus 2 plus 2. Now another, if you didn't want to use that trick, you can do what we did on prior worksheets, where you could plug in maybe this point here at negative 1, 0. Plug in negative 1 for x, plug in 0 for y, and you can come up with the same result. Alright, last one, 19. 19, we got a taxicab, has a flat fee of $3 plus an additional charge of $2 per mile for any part of that mile. So a half-mile travel is $5 and a 2 1/4 mile travel would be $9. So why would let's just make sure we understand this. So if you traveled a half a mile, you got your first $3 plus $2 per mile. Well, we haven't gone a full mile, but any part of that mile you're charging your $2. So that's where the 5's coming from, 3 plus 2. Someone that's gone 2 1/4 miles would pay the same as if they went 3 miles. So $2 per mile, so that's 2 times 3 is 6, plus the additional 3 gives you 9. So if we want to graphically represent this, we have two things to consider here. We got the total cost in dollars, and we have the miles traveled. And so I'm going to make a cost in dollars, our y variable, or our response variable, and the number of miles, the independent variable, or your x variable. So within the first mile, we said people are paying $5. So here's 5. It's going to be a constant no matter where you end up. If you do a half a mile or 3/4 of a mile or whatever, anywhere between 0 and 1, you're paying a flat fee of $5. Once you pass 1 mile, then we pay an additional $2. So if it was jumps from 5 to 7. So again, it's a flat fee between 1 and 2 at $7. At 2 miles, it's exactly 7 as well. So I'm filling in the dot. At 1 mile, it's not $7. It's actually $5. So the dot is filled in at 5. Open circle at 7. because that's kind of our starting point for anything above 1. And then between 2 and 3 you jump another $2, and this trend continues. And it tells us to go from 0 to 7, so we're going to stop at 7. So we got, just continue this going on here. And we'll stop there. Part A asks us to sketch the graph, and that's what we just did. Be sure to title each axis appropriately. We did that as well. Part B asks us what the domain and range is of, and it should say A of x. And so our domain is everything from 0 to 7, and it's what's stated above. If we change that to interval notation, we can write parentheses 0, comma 7 bracket. That's the domain. For our range, we have isolated points here, so we can actually, if you have a finite number of values within your range, you want to just list them out. So they may pay $5, 7, 9, 11, 13, 15, or 17. I think 17 is our other. Those are the only y values represented in our graph. There's nothing else. And so I'm going to put these in braces, and that's our range. So it is not an interval. And to make sure you check your understanding, are there more numbers in this interval 0 to 7, or are there more numbers listed here, 5, 7, 9, 11, 13, 15, and 17? And you should know that there are a lot more numbers in the interval 0 to 7. There's an infinite number of numbers in that interval. If I could spell infinite, sorry. Whereas here we can count them. We got 1, 2, 3, 4, 5, 6, 7. 7 numbers. And if you have a hard time seeing why there's an infinite numbers between 0 and 7, we're including all the decimal values. So 1.2 is in there, 1.2156 is in there. We can go on forever. You can always find an infinite number of numbers in any interval like that. Alright, lastly we want to write a piecewise function for a of x, and I'm going to do that up here because it's nice to be able to see the graph while we're writing this. And we have 1, 2, 3, 4, 5, 6, 7 different pieces, but the equations are pretty simple for your pieces. So my first piece is just this is the equation y equals 5, this one's y equals 7, y equals 9, and so on. So my first equation is a of x equals 5. Next one 7, 9, 11, 13, 15, and 17. So those are my 7 pieces. But those pieces only are within certain ranges, like it's only 5 from 0 to 1. So 5 if, let's see how they used if up here as well. So 5 if x is between 0 and 1. Don't include the 0, but include the 1. It's going to be 7 if x is between 1 and 2. Don't include the 1, but include the 2, and so on. It's going to be 9 if it's between 2 and 3. 11 if you're between 3 and 4. 13 if you're between 4 and 5. 15 if you're between 5 and 6. And 17 if you're between 6 and 7. So that whole thing is our equation of that piecewise function.